All right, so in this little lecture, we're going to look at a specific example of writing a method called total. Total itself will do pretty much a simple thing we've seen before in some of the exercises. The method will sum all the values from 1 to n. So it'll basically do 1 plus 2 plus 3 plus 4 all the way up to n, including n. So it's really all the method will do, and it'll return it back. So to be specific, let's just say it'll be the integer value. So the method itself will get a single parameter, which is n, which is the number of values, and it's just going to add them up. So it's going to do that with a loop, of course, and it'll just return it back. So let's take a look at what it will actually look like. So I've got a starter class here. Nothing in the main method. We're going to add some calls to the method that we're going to write. We're going to write the method in this area, but to make my life a little bit easier for any user input that I might be doing and any output, I'm borrowing my input word method from before, my input int method from before as well, and the only reason I'm keeping the input word is because I want to input an integer. And we know that the input int method calls the input word method, so we definitely need both of those. And then for display purposes, I don't want to do a systemout.print or anything like that. So again, I'm borrowing my two display methods. One to display strings and the other one to display integers. And why do I have both of them? For the same exact reason that my method which displays integers calls the method which displays strings. So I'm borrowing this idea. I've got some overloading of methods. I've got some polymorphism, if you will. So I've got a very flexible little program already, although it doesn't really do much. But my main method, I'm hopefully going to keep it as simple as possible. So what is this method going to do? Well, add all the numbers from 1 to n. So let's just start it here. So we assume that whatever the value will get passed in, n will be 1 or greater than or equal to 1. If it isn't, the method will actually take care of that, and it should return 0. So let's take a look at what the header will be. So the data type, it's going to return an integer because that's the summation. We're going to call it total, and it'll have one parameter, which is an n value, and that's what gets passed in. So there's our header, int total int n. The signature for it, we've got the method name total, and it's got one int parameter. So that's very clear. If we pass in anything else, of course, like a double or I don't know, anything else like a char, this might not work as well. So it's specifically designed for integers. So what we'll need in here is the return value itself. So I'll just call that one sum. And since we're doing addition, we'll initialize it to 0. And then we will just return the sum. There we go. So this program itself should actually compile quite nicely. There's nothing missing with it. There we go. Main method, of course, doesn't do anything yet. And our total method at least will return a value. It just happens to be 0. So let's write something up here in our main method. So we're going to need a value for n. So let's declare that, and we'll just call that number. And let's get that from the user. So we've got the value from the user using our nice little cool input int method down here. So it gets in the string, which is the prompt that we display to the user. We're going to display that to the user, get back a string, and then we're going to use integer.parseInt to take whatever's in that string, which is just characters, and return it back as an actual int value. So that was actually pretty nice that we could just do that in one statement. We don't have to worry about scanners or anything like that, and we've got the input. So let's go ahead and calculate the total. So we're going to declare another value here. We'll call this one, let's see, total of values, just to give it a nice long name. We'll initialize that to 0. And now the total of values is going to be assigned whatever total returns back. And the total method needs to know what the value of n is going to be, and we're going to call that number. So a little comment here, get value of n from user and some values from 1 to n, if you will. And there we go. And let's just display that back to the screen. So display total is total of values. Now in this case we're using the display method, which is just a string here. So we're not actually using the display for an int, but that doesn't really matter. We should get the value on the screen. So if we actually run this program, we should be able to at least type in the value knowing that it'll be 0 on the way out. So let's say it'll be the value of 5, and we see total is 0. Perfect. That's awesome. So let's flesh out the total method here. So we know that we're going to add them all together from 1 to n, so let's write a simple for loop. We'll initialize I at 1, and while I is less than or equal to n, because we want to get all the values from 1 to n. Each time through we're going to add it by 1, and now we're just going to do sum is assigned to sum plus I. I mean, we could probably replace this with something like sum plus equals 1, but let's not worry about that. For right now, we're just going ahead and we're just adding the numbers together. So let's see what happens now. So let's try a very simple value. If we do a 1, we should get a value of 1. So that's correct. If we run it again with 2, we should get a value of 3. We run it again with a value of 3, we should get a value of 6, which is perfect. So 1 plus 2 plus 3, that gives us 6. What was I saying about worrying about values that are less than 1? So if we put in a 0 in there, we should get back 0. And if we put in anything less than that, like negative 100, we get back a 0, which is exactly what we want to see. How are we getting away with that? Well, take a look at the initialization. So we're initializing our sum to 1, or to 0. And the for loop here, the condition is while I is less than or equal to n. So if n is equal to anything less than 1, of course this loop will never execute, which means sum never changes from 0, and then it just returns back the 0. So this method total is actually very, very powerful. It self-checks. It only adds 1 up until n, and anything less than 1 is just going to return to 0, which is exactly what we want. So that's perfect. It's a small little method and it works exactly the way we want it to. Now, what if we wanted to change it up a little bit? What if we wanted to change the method so that the method will int sum all the values from m to n? So in this case, we now have 2 values. So we don't want to always do it from 1. We want to do it from maybe 10 to 15, or from 1,000 to 2,000. We want to be a little bit flexible here with our method. We don't want to just do it with one value n. We want to provide the full range. So if we go back to our method here, let's not modify this one. It actually works very nicely. It goes from 1 to n. Let's write another one. So we'll add another one up here. This one will also return back an integer. We'll also call it total, but in this case we'll have 2 parameters, m and n. So this one will add all the numbers from m to n. My typing is getting a little bit exhausting. I think I'm getting a little too lazy in my typing. So how do we want this one to run? Well, we can't really call this one directly. This method is actually very custom. It encapsulates exactly the idea of going from 1 to n. But we can at least borrow the code. So let's go ahead and borrow the code up here. So I'm just going to copy paste it. And I only have to make one change, and that's initialize I to m. So this one sum, let's see, it goes from m to n. That's the only change I need to make. Otherwise, we're still summing properly. Sum is assigned sum plus I, and we're still returning the sum. We still initialize to 0 up here, and let's consider that for a moment. Depends on what we want to do. So in this case, we assume that m is less than or equal to n. But what if m is greater than n? What should we return back? A 0, value of m, a value of n. So in this case, what I'm going to dictate for this method is if m is greater than n, so we're reversing, we're going from, let's say, 20 to 10, which doesn't make any sense in terms of summing, then we're going to return back 0. So in this case, this method works exactly the way it should. It's perfect. We return a 0 unless the loop actually executes. And the only time the loop will execute is if m is less than or equal to n. So let's actually test this out. So let's just modify this program just a little bit. We're going to need another value here of number. So let's do int m. We'll start that one off at 0. Let me change these completely here. So I'm going to call this one start. So that will be the value of m, and int end. That will be the value of n. So it'll be like different from the other call. So we'll go down here and we'll get the value of m. Call that the start. And then we'll also get the value of the end, which is n. Perfect. So we've got those. Now we're going to actually call it. So let's see. Total of values is total going from the start to the end. So there's our value of m to n. So when we call this method, start will go and become m, end will become n, and it will return back an integer, which we're just going to store back to total of values, overwriting whatever value we got in the previous one. Excellent. So one quick review is we've got two methods now called total. So we've got some polymorphism going here. We've overloaded the name total, so there's actually two of them. So how does Java understand which one to call? Again, it's going to be looking at the signature quality of the method, what we're also referring to as the method header. So in this case, we've got total, which has only one integer parameter. So the match is for this method. For this one up here, we've got total, which has two integers. So we've got total and an int and an int. So obviously, this is the one that's going to get called. So let's take a look at this. We're going to do a quick compile. We're going to run it. So this will be for the very first one. So let's say we've got a value of 2. That should give us a value of 3. My formatting isn't perfect, so just if you're following along, I'm going to clean this up a little bit, and then we'll run it again. So we know that the display method does not have a new line, so I'm just going to concatenate a new line here. And I completely forgot to display the total down here. So I'm glad I didn't continue. So total is total of values. And I could have just copy pasted it, but I really do enjoy typing on this brand new keyboard. So there we go. We'll compile it. We will run it. So now we've got the first one. So let's do a value of 2 again. That should give us a value of 3. Perfect. Now we've got from m to n. So let's try this out. We'll go from 1, and then we'll go from 2. That should give us a value of 3. Excellent. So this method is working perfectly fine as well. It works exactly the same as the other one, except now we can control the value of the start position. So it's not always going to be a 1. We've got some flexibility going on here. Excellent. So one quick note. our code isn't as good as it could be because these two methods are actually very similar to each other. So a question, could one of the methods call the other? So we've got two of these methods. They're doing very similar actions. Is there a possibility we could have one method call the other one? So very similar to how we have down below with the display and the input methods. So we've got the input int method, which is very similar to the input word method. And we've got the display method for an integer, which is very similar to display of a string. And so what we did, well, we had one method call the other one. So we had the method that wasn't as complex call the one that was a little bit more complex because it did almost everything. So if we look at our two total methods, the one that goes from 1 to n is very similar to the one that goes from m to n. And if you think about complexity, the one that goes from m to n is slightly more complex because it's got that flexible starting position. Whereas the total method here, which only goes from 1 to n, has a very hard starting position, which is 1. So could we have the total method here that goes from 1 to n actually call the one that goes from m to n? Yes, I've been hammering about that for the last few minutes, but yes, we can actually do that. So the simplest way to do it is in one line of code. Since the method above does exactly what we want, why don't we just go ahead and say return the value that the other method has from going from 1 to n. That's it. So this one, call the method total that goes from m to n. So now we really only need one totaling method. The other total method is just a reflection of the other one, where we're controlling the value of 1. So let's try that. So the very first time we run it, so in this case, it looks like it's the call to the old method. Put a value of 2 in there, we should get a value of 3. But we know that it's actually calling the other method, the brand new one that we've written. So in this case, if we type in the value of, let's say, 1 again, and the value of 2 as the starting position, again, we get a 3. So yes, we've written two methods to accomplish what looks like a fairly simple task, but really now we've only got one method that does it. This is just a pale reflection, if you will, of the other method. And that's actually quite interesting. So if we look at this method, we can see that, yes, the total of m to n can be called by total of n. So when we were looking at writing this method, we thought about being lazy, but the laziness didn't come in having that simple method. The laziness came by having only one method which was slightly more complex, and then just modifying that simple method to be even simpler, one line of code to call the method up above. Now, the one thing about these methods is the call itself. So when we're calling total, it doesn't matter which one, we're passing in the value of m and n or just n. And we're only returning a single value. And that's how methods in Java work. There's other languages like Python, some of the complex scripting languages, which can actually return more than one value. And that's through some sort of mapping when you do a call to a function or a method. Java doesn't have that. You can only return one value. So if we look at the total value here, or the total method, it returns back a single integer. There is no syntax where Java could say, I want to return an integer and a string and a double. That syntax doesn't exist in Java. It can't do that. And the reason it can't is because the return type, that return data type, is not something that is part of the signature of the method. So we can't return more than one value. It can only return one value. And of course, it has to be some sort of primitive. Even if it's a string object, we're returning back a memory address, so it's still just one value. It's always one value. But how could we return more than one? So how to return more than one. And an example for that is min and max. So with min and max, we want to calculate both of them often. We want to get the minimum value and we want to get the maximum value. But how could we return back more than one value? Well, what we can do is use the idea of a global variable, or what is referred to as an instance variable. And this is something which sits outside of a method and has the ability to be accessed by all the methods within the class. And this is going to be a lead up to writing classes and objects. But this is a very fundamental aspect. So uh, let's clean up some of this code, and we'll go back and rewrite the min and max, and we'll do it for 3 values. So we'll do the min and max for 3 values. If I could type it. There we go. So let's take a look at what that seems like. All right, so here we have a small little program, and what we have is a main method which declares 2 variables here, min and max, and that's where we're going to store the minimum and maximum results. We've got 3 values we need to determine the min and max for, so val A, val B, and val C, and we've just given them some values here of -5, 2, and 33. And here's our method calls. We've got figuring out the minimum of those 3 and figuring out the maximum as well. And then we'll just display the result. So let's take a look at the methods themselves. So we have minimum here. It returns back an integer because all our values are integers. We've got 3 parameters, an int A, an int B, and an int C. And to figure out the minimum here, we declare a local variable called min, which is just within the minimum method. And if A is less than B, we're going to return back an A. If that is false, we're going to return back a B. So one way or the other, we're returning back the minimum of A and B. And down here, we then introduce C. So the minimum is then comparing minimum against C. And if minimum is still the minimum, we return that value. But if C is the new minimum, we return that and store it. And then we do the whole return overall of minimum. So that's how we can get the minimum of 3 values. Same exact idea for maximum. So in this case, instead of looking at whether A is less than B, we look if A is greater than B, return A, and otherwise B must be the maximum, and very similarly with max and C. So this is how we would have written the method so far. But to figure out the minimum and maximum, we actually have 2 methods. So let's run this and see what we get. So our values are -5, 2, and 33. So if we compile this guy, we should get that the minimum is -5, which is correct, and the maximum is 33. And just to really test out this program, let's change the value here to -200, and so that should be the new minimum. And we see that it is the new minimum, and if we change value A to be 77, that should be the new maximum. So let's make sure that that works out as well, and we see that 77 is the maximum. So our program works perfectly fine. But could we write one method that looks like this? Could we write a method that calculates both the minimum and the maximum instead of having 2 separate methods called minimum and maximum? And in a way we can, and in a way we can't. Because as I was just stating, we can't actually return back more than one value. We couldn't have something where we return back the minimum and the maximum, because we have a data type. That's all we can represent. We return back an integer and an integer. How does the calling method up here in the main, how would we know if the minimum, let's say it looked something like this, val A, val B, val C, how do we know if the minimum is the first thing that gets returned and maximum is the second? There's no name here. Java doesn't provide us a name and the return data type. The return data type isn't even part of the signature. Java doesn't even know how the method should be laid out. All it knows is the name of the method and the fact that there's 3 integers. In the method header, we do have names for the parameters. We know that the first one is called A and the second one is B and the third one is C, which we only use within the method itself. But we can't dictate anything like this. Java doesn't have the capability to do this. So how again do we return that value? Well, it comes down to the fact of we don't return anything. And I'll explain that in just a moment. So we need to make that into a void because this method returns nothing. It's going to still figure out the minimum and maximum, but it's not going to return anything. What it's going to do is actually store the minimum and maximum as 2 variables which are outside the methods. So what I'm going to do is move these 2 up here. Now, because they're in the main method, or they're in the program class, I have to make them statics, just like the methods themselves. So there we go. We've got the 2 laying out there. So these are actually called, for this program, global or instance variables. And by global, it means that these variables here, min and max, are accessible by any method inside this class, whether it be the main method, the minimum method, or you know what, even the display method down below could even access them. Although I'm not quite sure what the display method would be doing with them, since the display method is supposed to only display the parameter. Encapsulation again, encapsulation. So how could this work? Well, what we can have is that the main method sets up its own variables here, val A, val B, and val C, just calls them integers, and those are just for the sake of calling the methods. So there's nothing extra special with those. But when it returns the values back, you can see that minimum is not declared inside the main. It's actually declared outside. When this program class is executed by the virtual machine, these 2 variables up here, these global variables, instantly get allocated. They become instantly available, which means any method can store values into them and retrieve values out of them. So what we're doing in the main method here is we're actually trying to store values in there. But what I'm going to do in the main method is just remove this. We're not going to do anything with them. And if anything, we're not even going to use the minimum and maximum methods. We're not going to do that at all. What we're going to do is copy these instructions here from outside these methods. Since we don't have these methods at all, they don't actually exist. We're going to have this one method called min and max get the minimum and also get the maximum, which means we don't declare them inside here either. So these access the global variables. So when we call this method, so we're going to call it up, let's see, I'm going to call it down there, do a little cleanup here. Apologies for getting a little bit of messy code. There we go. So what we have is the local variables which sets up our value A, B, and C. We're going to call min and max. We're going to pass in val A, val B, and val C. So those become the 3 parameters A, B, and C. Inside the method itself is going to determine the minimum using the exact same algorithm as we had before of A, B, and C. We figure out the minimum. We also figure out the maximum. But you will notice that there is no return statement. We don't need one in this case because this method does not return anything. This method is a void. It returns nothing. But as soon as it's finished down here, once it gets to this point down here, this method is finished. Having done the assignment to minimum and maximum as global variables out here, which then the main method accesses directly. So what we've got is that the main method calls the min and max method. Min and max are set by that method, and then the main method goes ahead and uses them. So it's interesting that these two variables out here are just acting like that as variables, but it's information that's being shared by both the main method and the min and max method. This one sets up the values, this one goes ahead and uses them. So let's see what actually happens here. So we should get the same idea that we had before, so that the minimum is negative 200, the maximum is 77, which is exactly what we had before, but in this case, we have only used one method to do both of those duties. So in a way, this new method, min and max, can return two values, whereas by definition, methods can only actually return one value. Now, this is actually pretty interesting. So, how do we return more than one? We use global or instance variables. If I could type it in right. Now, the one caution about this is do not use this idea. Using the idea of global and instance variables this way is not very good at all. It's not something that you should be doing. Why not? Well, let's take a look at this method here. So min and max, for it to actually function, it depends on these two local variables here, or sorry, these global variables, min and max, being part of the class. You couldn't easily say to another programmer, hey, I've got this wonderful method here called min and max. It figures out the minimum and maximum of 3 values. And the other programmer goes, awesome, I don't have to do the work. Why don't you just send me that method and I'll paste it into my code? And you go ahead and send it over to them. They paste it in and they compile them. And then they see an error similar to this. They see something along the lines of variable min doesn't actually exist. And I think there's a follow-up to that. Max doesn't actually exist. And they're telling you that, hey, you gave me a method that's incomplete. You didn't even declare these min and max. And you're thinking, oh, you're right. When I wrote my program, I had them declared as globals. This is actually the problem of using this approach to solving this problem of having a method return more than one value. We call this tightly coupled code, which means this method here, min and max, is tightly coupled. It's highly associated with the rest of the program. You can't easily just remove this method and put it anywhere. This has to exist within this class, or the other programmer has to know that they need to declare these two variables. This is not an example of lazy programming. This is actually rather complex programming. A lot of instructions to do what looked like to be a very simple thing. So tightly coupled code is not something we ever want to do. We always want to try and write what is referred to as loosely coupled or uncoupled code. You should be able to take your method and give it to anybody else and say, here, run this method. It stands by its own. We do that for display. We do that for our input method. We use it so much. Even the math.min and math.max, you don't need to know anything else except for the fact of how do I call this method. So do not use this idea. Now, of course, that's a lie, because this is actually one of the fundamental ideas of writing classes and creating objects. Tightly coupled methods is actually how classes function. But the idea of a class definition is not the same as just writing a method on its own. The idea of a class is that the data and the methods within the class are related to each other. So if you think of a string method, when you say string.length, when you use that length method, you're asking about the length of the data within the string. So it depends on how many characters it has. That tight coupling of the method and the data is how the string class functions. But when we're looking at this method or this class here, this is just a regular program class. There's nothing special about this one. It's just got a main method which figures out the minimum and maximum. How should it do it? Well, it should probably do it in the easiest way possible. we're not creating any classes or objects here. We're just writing a simple program. So what you should do is have independent methods, which are one to calculate the minimum, one to calculate the maximum, very similar to how we did before for 3 variables, or how the math.min and math.max methods work. So that's it for this introduction to methods. The next little virtual lecture is going to be about classes, and we're going to start writing our class definitions, which have data and methods tied together. So that's it. I'll see you in the next virtual lecture.